University Technology Malaysia, the Faculty of Built Environment and Survey.
Hi everyone, my name is Yap. So we are from University Technology of Malaysia. So today we are very glad to be here and sharing with you all about our group project for survey and mapping. So today our topic is about the urban 3D plan using integration of UAV, orthophoto and interferometric synthetic aperture radar image, which is the INSA. So followed by our group members, which is Fong Qing, Fasihah, Maisarah, Miza, Kon Hua Xian, Valerie, and myself, Yap Wei Kang. For the introduction, UAV orthophoto and interferometric synthetic aperture radar image is a common technique used to perform urban 3D plans. So for the unmanned aerial vehicle, which is the UAV, like a drone, are very common use in order to doing some surveying jobs, and very wide use in geographic information system, which is the GIS, and photogrammetry in order to collect data and perform 3D plans or maps. So for the interferometric synthetic aperture radar, so it is a technique that using radar to measure the change in land surface altitude, and it can be attached to a satellite or a airborne system, which is like aircraft, to perform a survey job.
The definition of UAV and INSAR. The full name of UAV is Unmanned Aerial Vehicle. UAV, known as a drone, is an aircraft without a pilot, crew, or human passengers. UAV is a component of an Unmanned Aerial Vehicle System (UAS), which includes a ground guard and a communication system with a UAV. UAV flights can operate under remote control by human operators as long-range pilot aircraft (RPAS), or with varying degrees of autonomy such as autopilot assistance to fully autonomous aircraft that have no provisions for human intervention. Interferometric Synthetic Aperture Radar is the full name of INSAR, a radar technique used in geodesy and remote sensing. This geodetic method uses two or more synthetic aperture radar (SAR) image to produce a digital map of surface deformation or altitude, using phase difference of wave returning to a satellite or aircraft. This technique has the potential to measure millimeter scale deformation change over a period of day to year. It has application for the geophysical monitoring of natural hazard.
For the technology development, UAV was motivated by military applications such as unmanned inspection, surveillance, and also reconnaissance. UAV also paired with digital cameras and GNSS systems, which are required to navigate platforms, estimating acquisition spots, and also performing direct georeferencing. Interferometry synthetic aperture radar, which is known as INSAR, has been the most accurate technique to monitor Earth's surface deformation until this day.
Our objective of this project, the first is define the theory and concept of UAV orthophoto and interferometric synthetic aperture data. The second is determine the development of instrument and application of UAV and INSA. The third is explain in detail the process to conduct the selected application from planning, instrument, software and hardware, data acquisition, methodology, calculation, error, accuracy, and analysis. The fourth is determine the output of urban 3D plan by using UAV and INSA.
For the theory of concept, UAV basically carries a full combined camera which is suitable for low altitude aerial photogrammetry. INSAR is a weather independent, which means that INSAR can sense any urban areas clearly in any conditions, whether it is bad condition or good condition. Orthophoto is a geometrically corrected aerial photograph. For example, the image scale that we produce have to be accurate just like the given map projection. UAV is also capable of performing the photogrammetric data acquisition with mixture of SLR, single reflex lens, digital cameras, and it also can fly in manual, semi-automated, and autonomous modes.
So for the instrument hardware and software part, so UAV orthophoto are using aerial camera as their instrument to collecting data. For the INSA, they are using radar electronic assembly, which is the REA, and antenna to collect and receive the data. For the hardware part, UAV orthophoto are using drone, and for the example, which is the fixed wing drone, single rotor drones, and multi-rotor drones in VTOL. And then the INSA, they are using space-borne method, which is the satellite. So for example, they are using Sentinel satellite and RadarSat 2. Alright, so lastly, the software part, which is the UAV orthophoto are using the drone deploy. So this software is an easy software that can perform a 3D modeling and mapping function. So it can also perform several in-field data before back to office and upload a high-resolution 3D in several formats and share with their clients. So for the Synthetic Aperture Radar, which is the SAR, they are using Pyro SAR. So this software is a Python system to handling a large-scale SAR and process the gamma and snap handling capabilities. So it is specialized in dealing with metadata, designing of the process, information for advanced examination, and choice for sending out information to 3D shape. So next, type of data. UAV orthophoto are in the aerial data. So the output for this data are orthophoto, also known as auto rectified image. So the data will be geometrically corrected, just like the photo on top. So for the interferometric synthetic aperture radar INSA, they will produce out in point cloud data. So just like the image on bottom. So that's all from me.
So now I will explain about the methodology of works. In primary data, we need to define the quantitative assessment and the qualitative assessment. Both techniques can be split into two components, which is the auto image generation process and the auto image quality assessment procedure. So looking at the left figure, this figure shows the auto image generation procedure. There are 5 processes, which is the interior orientation, exterior orientation, DTM generation and edition, auto image generation, and the mosaic creation. And looking to the right figure, this figure shows the auto image quality assessment procedure. So looking to the geometry assessment, the checkpoint and the overlay map layers on auto image are used to determine the geometric position of generated auto image for quantitative geometric position assessment. Besides, the image histogram analysis and the subtraction, contrast, and noise check are used to determine the radiometric position of generated auto image for quantitative geometric position assessment. Okay, in our secondary data of the methodology, actually we define the unmanned aerial vehicle UAV and the interferometric synthetic aperture radar through the journals, articles, and reports. Before going into depth about how to make a genuine orthophotos, a few often used abbreviations should be clarified, which is the DTM digital terrain model, DBM digital building model, and the DSM digital surface model. So the figure at the right hand side is the flowchart of the works to produce a 3D plan. So later my friend will explain it. Thank you.
Hello everyone, my name is Dan. So now I'm going to explain the plan of works for this project. For the planning of UAV, the first one is boundaries or borders of the photograph area. The dimensions of the photograph area depends on the capability of the motor installed in the UAV. For the next one, model of the camera and its parameter. A better digital camera can help improving the quality of output image. For the third one, expected scale of photographic image. On the photographic image, the focal length of camera and height of the UAV can be used to calculate the accuracy of the expected data or image. For the next one, longitudinal and transversal overlapping of photographs. It must be calculated before the UAV flight, and because it can help the quality of output image. And fifth, flight direction. Every UAV has their own direction, which is north, northeast, east, southeast, south, southwest, west, and northwest. But with the case studies, we found out from east to west or north to south is the most suitable direction for photogrammetry. And for the next one, flight speed. And flight speed can be affected by wind speed, and different region has different wind speed, so we have to determine the wind speed and the flight speed of UAV before the UAV flight. And for the last one, flight height. And the height depends on the fog of the day, so we have to figure out what day is less foggy, because less foggy day is more suitable to flight. For the first one of blending of inside image is statistical consideration for determining size of the sampling unit. This blending is to solve the question of how big the area is that we want to photograph and should be to qualify as a sampling unit. For the second one is determination of sample size for model development. This plan is used to establish how many such samples are required to assure a nearly accurate relationship between SAR backscatter and the target parameter. For the third one is determination of validation sample size. Validation is an important part of any statistical method-based investigation, so it is necessary for this planning. For the last point is identification of sampling locations on SAR image. We have to overcome the challenge by using a GPS-based mobile mapping to track the boundaries of the area. Okay, now I'm going to explain the process of work for this project. For the process of UAV photogrammetry, the first one we have to perform the area triangulation. During the area triangulation, the root mean square must be calculated and satisfied, and for the ground control points must be determined, because it is very important to this ratification process. And for the next one, DSM was created by using the area triangulation, and DSM is used to auto-ratify the image in the project. And after the auto-ratification from DSM, so we can obtain the individual auto-ratified image, and finally a mosaic image is formed. For the process of SAR image, the first step is pulse compression. Pulse compression is a technique for increasing pulse radius range resolutions. And then, before SAR image form, there are two basic algorithms needed to be processed, which is global back projection, which is GBP, and range migration algorithm, RMA. So for the GBP is used to produce the side image in the form of 2D spatial domain, and the RMA is used to produce the side image in 2D frequency domains. So at the below, it is the formula and the figure to explain these two algorithms.
The first process is import the image. We import the UAV images to any suitable software that we wish to use. The second step is require us to align the photo, which shows the position and orientation of the photos. Image alignment, known to be one of the important tasks to jointly exploit, integrate, or compare two or more data images. These data are basically taken at different times from different viewpoint and sensor. The next step that has been used to process the data is photo meshing and texturing. The 3D textured mesh is a reproduction of the edges, faces, vertices, and texture of the area that has been shot by the drone. The model is one of the most important tools that can be used for visual inspection or any essential project. Photo meshing can be defined as a process that helps to turn discrete point cloud data into continuous 3D surface of the building. It is constructed in the triangulated irregular network form. However, texturing is a process projecting the texture from the original photo to the surfaces of the model. If there are some particular areas that have been imaged at more than one photo, the projected texture will be mixed from these images. Then, after all the processes have been done thoroughly, the orthophoto and digital surface model DSM will be produced. The orthophoto have to initially perpetrate geometric corrections in order to transform the coordinate from WGS 84 to the local coordinate RSO, and a detailed survey will be processed using appropriate software. The first step of interferometry process requires us to go through an image co-registration process. The interferometric information is the response of the phase difference from a target point that sends at two different radar positions, which are master and slave position. These two responses represent the radiometric value and the phase of two pixels that have been placed on both positions. It is necessary to have the two superimposed images by extracting the common area between two acquisitions. By doing so, the phase difference of two pixels can be extracted. In order to have the best image co-registration, a method that is based on phase correlation has to be developed, which use the Fourier transform properties to calculate the shift value. The Fourier transformation helps to displace the two images into a phase shift frequency in the spectral area. Calculating the translation between the two images requires us to observe the phase shift between their Fourier transformation. The next step that needs to be done is calculating the baseline. Baseline is known as the key parameter to choose the interferometric pair, which consists of master and slave image. In this step, we need to estimate the value of baseline by interpolating the two orbits that are corresponding to the images using language interpolation. The baseline can be calculated using the following equation. The next step is filtering the interferogram. The generated interferograms are usually characterized by noise, which can be happen due to the speckle noise, which is the result of the spatial and temporal decorrelation between two images. Laser has been widely used in various high-precision interferometry techniques for its ability to strongly coherent the light source. However, it can produce coherent noise at the same time. As a result, it may lead to the difficulties in classifying and restoring data information. The other factor that may affect the accuracy of the generated interferograms is geometric distortion, which refers to the improper positioning of scatterers in the output with respect to its true position. In order to have a better exploitation of the topographic phases, the noises in the interferogram have to be derived by using suitable filtering methods such as vector filtering. Vector filtering is known as one of the processes that use spectral and spatial information in order to remove the noise. This technique can be implemented using the following equation. The last step is unwrapping phase. The measurement of the corresponding elevation is quite ambiguous. This method can be solved by conducting phase unwrapping process. It is one of the important interferometry techniques that is used to generate the DSM. This step considered as the most delicate in rough terrain, building and steep slope. This process helps in providing smoother structure without discontinuation, which produce a conical shape of the filtered interferogram as shown in the diagram below.
These two images are the sample output of 3D orthophoto image and the 3D InSAR image.
There are 4 ways that we can apply in order to get an accurate data using UAV. The first one is by focusing on the aspect of the devices itself, and the second one is by using high resolution satellite image. The third one is by controlling the ground control point, and the last one is by using calculation method. UAV is extensively used in various types of field such as archaeology, agriculture, scientific research, and even used for military purposes. UAV is known as one of the alternative ways that helps the acquiring data process with lower operating costs, low manufacturing and operational costs. There are several aspects that should be highlighted in choosing UAV devices or system, such as size and weight of payload, stability and vibration, number of people needed to launch and control the devices, level of plotting skill, minimum airspeed that required when running the UAV devices, and minimum size of takeoff and landing area. Ground control points can be defined as points that placed on the ground or the earth surfaces, which the positions are accurately known and can be easily identified and recognized through the images. Time needed for the observation of each GPS point is approximately 15 minutes. It can be established on any permanent objects such as street corners, drain edges, and crossroads. This method is basically used to overlap 2 or more UAV images. By doing so, it helps to produce the mosaic orthophoto and topographic map. The selection of each control point is very important since it will affect the images itself when doing the overlapping process. It is preferably to collect 5 or more control points for each image that is located in each corner and the middle of the image. Hence, it will prevent any distortion to be happen, especially when the images are overlaid to each other. The last step required is to do calculation of the root mean square error. Root mean square error is generally used to measure difference values between the coordinates and reference coordinates that have been observed. The RMSE result will show how accurate the values of the dataset are. The following is the equation that can be used to calculate the RMSE. As for the accuracy of InSAR, one of the approaches that can be applied is making a strategy for tie point matching. Tie point matching have 2 different factors, which are the size of the window and the matching strategy. One of the methods that we can apply for tie point matching process is technique that based on spectral maximization. In this process, a small window that's centered around the tie point in the master image is selected and moved on the slave image. The matching result is considered as the best one if the peak of the Fourier transform of the master image product multiplied by the complex conjugate of the slave image is maximized. However, this method requires a lot of calculation. The second method is image cross-correlation maximization. Image cross-correlation maximization is one of the methods that has been introduced to combat the issues. The cross-correlation coefficient is used as a parameter to evaluate the matching result. There will be many possible matching windows that have the same size. However, it will be graded as the best matching result if the matching images have the highest correlation coefficient. The central pixel of the two windows will be regarded as the collected corresponding point of image. Since we have no data to be presented, so I will only brief about these two types of analysis that can be carried out in this study. So basically, we have two types of analysis, which are qualitative and quantitative assessment. Quantitative analysis is mainly about the numerical quantity that can be done through the process of calculation and computation of the data. Quantitative assessment can be carried out by calculating the root mean square error using the formula mentioned before. However, qualitative assessment is a technique that related to the visualization of the map using the concept of digitizing features in the image. The analysis can be carried out by comparing digitized features from InSAR image using ArcGIS software, for example, and UAV images using stereo analysis module that can be found in AirDesk software.
The last part is conclusion. In this project, we have studied theories and concepts about the technique of using UAV orthophoto in urban 3D planning and synthetic interferometry aperture radar (SAR) image. The advent of drone UAV technology is changing the way surveys are conducted, making them accessible to a variety of industry. Drones offer great opportunities for surveyors and GIS professionals. Besides that, InSAR is a proven technique for measuring ground motion. Satellites record image of Earth, and this image can be combined to measure the movement of the Earth's surface. It gives many contributions in surveying and mapping, currently in line with the development of world technologies. By learning more about this technology, it can help researchers or surveyors to generate more ideas and a lot of understanding about the applications and techniques used in surveys and mapping.
Thank you. Please give a like and leave a comment if you have any question you want to ask to us. So thank you everyone for watching our video.